So today we're going to talk about right triangle and the trigonometry function. So first of all, we need to talk about what is a unit circle. A unit circle meaning that a circle's center is at the origin of the coordinate plane and the radius of 1. So the circle that we're seeing on the left is our unit circle with a radius of 1, and the center is the origin of the coordinate plane. Then if we have a angle in a standard position, such as this one, and then know that if with this angle we can form a triangle inscribed in the unit circle, then we will have our right triangle. Look. It has to be inscribed in the inside the unit circle. So here we will have our right triangle. Our trigonometry function, it was going to be based on this right triangle, which is the one that inscribed inside a unit circle. So here is the definition. A trigonometry function is given any right triangle with an acute angle of t. Let's say this angle is t. We have the definition of sine, which is the handwriting would be sine t is equal to the opposite side over the hypotenuse of the triangle. So now let's look at the angle t. Which one is the opposite side? So we have side A, B, C. So the opposite side of the angle t should be B, right? So hypotenuse would be the longest side, or the side that opposite to the right angle. So I have the opposite side C. Oh, sorry, that's hypotenuse. B over C. So here's our sine. So the definition of cosine is we use cosine, COS, and it's equals to the adjacent side over the hypotenuse. So the adjacent side of t should be A, so would be A over C. Okay, the next is tangent. So tangent, we use TAN. Tangent T is equals to opposite side over the hypotenuse, which is the opposite side of T is B, the adjacent side is A, so it's B over A. So here is the definition of trigonometry function. So here is some exercise. Let's take a look. So that applies to all the triangle. It doesn't have to be the triangle in the standard position inscribed in a unit circle. So here is a right triangle. We have 1, x, and y. So now our sine, let's say sine theta, is equal to the opposite side over the hypotenuse. The opposite side would be x. Oh, sorry. This should be the the opposite. This should be x because this is horizontal, and here's y because that's the vertical part. Should be x over 1. And then cosine theta is the should be y over 1 because it's the opposite over the hypotenuse, so which is y over 1, and the cosine is going to be the adjacent over the hypotenuse. The adjacent is x over 1, and then tangent theta is the opposite side over the hypotenuse. The opposite side is y, not hypotenuse, the adjacent. So it should be y over x. So that's how we find the trigonometry function. Now, let's try another exercise. If you're given a right triangle, such as can be in a different position, like this one, and this is our alpha, this is 17, 15, and A, right triangle. Now, I want to find the cosine alpha, sine alpha, and the tangent alpha. So let's take a look where alpha is. Alpha is here, so the opposite side, or let's find the cosine alpha first. Cosine alpha, so the adjacent side is 15, and the hypotenuse is 17. So in this case, our cosine is 15 over 17. And the sine is the opposite over the hypotenuse. So the opposite would be what? 8 hypotenuse is equal to 17. Now tangent. Tangent is the opposite one over the adjacent one. So now let's take a look which one is the opposite, which one is the adjacent one. So the opposite is the angle that opposite is the sine that opposite to the angle, which is A is the opposite side and 15 is the adjacent side. So our tangent is equal to, tangent alpha is equal to 8 over 15. Okay, so next we want to talk about what is the reciprocal function. So we have 3 reciprocal trigonometry function. It's called secant, which is the definition of secant is SEC. We write it as SEC. And the secant is equal to the hypotenuse over the adjacent side. And then we have cosecant. The definition of cosecant is CSC is equal to the hypotenuse over the opposite side. And then we have cotangent. Cotangent is COT is equal to the adjacent over the the opposite one. Now you might notice that, okay, let's start with the easiest one, which is the tangent and cotangent, right? Because this is quite obvious. What does that mean, co? Remember, what is tangent? Tangent, by the definition, is the opposite over the adjacent, right? But cotangent is the adjacent over the opposite. That means they are the reciprocal of each other. So that means our cotangent is equal to 1 over tangent. Now, similar to cosecant and secant, now take a look at secant. Secant is equal to the hypotenuse over the adjacent. If you flip them, remember if it's adjacent over hypotenuse, this is what? This is going to become cosine, right? So that means secant is the hypotenuse of cosine. Now, next one. Cosecant is, the definition of cosecant is hypotenuse over the opposite side. And our sine is the opposite over hypotenuse. So that means our cosecant is the reciprocal of the sine function. So here is the definition of the reciprocal function. Okay, when we talked about the trig function, we are referring to the relative position of the angle. So that means sometimes your sine could be other angle's cosine. Now, here is the example. For example, I have a triangle here. So this is the right triangle. And we have two lines, alpha and the beta. And we have the line x, y, z. Now, I want you to find what is sine alpha. Sine alpha is equal to the opposite side of alpha, the angle alpha, over the hypotenuse. So the opposite side of alpha is y over the hypotenuse, which is the side opposite to the right angle, which is z. Now, let's look up cosine beta. Let's see, this is equal to what? Cosine beta is equal to the adjacent side over the hypotenuse. So which one is the adjacent side of beta? Which is wide, right? That's the adjacent side of the beta. So we have a y, hypotenuse, it would be the same over z. So look, sine alpha is equal to sine beta. This actually is called cofunction. We will talk about that later in the next section. Okay, now I want to spend more time to do more exercise since we just learned the reciprocal function, which is secant, cosecant, and the cotangent. Now here is a triangle. I try to draw a different triangle each time so you will get more familiar with the right angle in a different position. So in here we have 15, 8, 17. And here is our alpha. Now, I want you to find sine alpha, cosine alpha, tangent alpha. Also, secant alpha, cosecant alpha, cotangent alpha. Now, let's start with sine. Sine alpha is what? The opposite side over the hypotenuse, which is 15 over 17. Cosine is the adjacent over the hypotenuse, which is 8 over 17. Tangent is the opposite over the adjacent, which is 15 over 8. Secant is 1 over, there's a multiple way to do it. Secant is 1 over, remember that this is the reciprocal of cosine, right? So that means secant alpha is going to be 1 over cosine alpha. So that means we need to flip the cosine, which is 17 over 8. Or you can remember that this is the hypotenuse over the adjacent. Okay, cosecant is the reciprocal of sine alpha. So our sine alpha is equal to 15 over 17. So that means the cosecant alpha is 17 over 15. Or you can remember the definition, which is the hypotenuse over the opposite side. Cotangent is the reciprocal function of tangent. So cotangent alpha is equal to 1 over tangent alpha. And this is equal to, oops, eight over 15. Or by the definition, it's going to be the adjacent over the opposite side. So that means in this, finding the reciprocal function, which is secant, cosecant, and cotangent, we have a two-way to do it. One is this one. Find out what is the reciprocal function is and just flip it upside down. The second way to do it is, oops, find out the definition. By definition, and then find the corresponding number to find out where is secant, cosecant, and cotangent. That's it for this section.